So in this video, I'm going to go through a couple examples from your remainder theorem practice set. You're doing every other even, so you'll start on 2, you'll skip 4, you'll go to 6, etc. Okay, so I'm going to do example 1 for you. We are evaluating the function at x equals 2. In other words, we want to know what is the value of y when x is 2. And based on the remainder theorem, what we can do is just divide by x equals 2. And let's use synthetic division. So my first term is x cubed. It's got a -1 leading coefficient. And then notice I'm missing my x squared term. So that's 0x squared. Don't forget how important placeholders are in synthetic division. If you're missing anything going in descending order, so 3 should be followed by x squared, then you need to put in a placeholder. Then we have 6, -7. Okay, so remember synthetic division, we're going to bring down our leading coefficient of -1. We're going to multiply -1 times 2, which is -2. Then we add -2. -2 times 2 is -4. Add 2. 2 times 2 is 4. -3. So when x equals 2, y equals -3. In other words, f of 2 equals -3. So your answer is -3 because the remainder theorem tells me that when I evaluate it at that point, we're looking for that y value. So that's how you're going to do this first set of examples. Again, that means that the point 2, -3 would lie on this polynomial function somewhere. Okay, in 6, look out for placeholders. Just like we did in that last example, it's longer, but remember the process is identical. Okay, 7 is now asking you to state if the factor here is or the factor that's given, if it's a factor of the polynomial. So we're going to use the same process of the synthetic division, and what we're looking for is a remainder of 0. So the goal here is remainder 0, because if you have a remainder of 0, that means that that is actually on the x-axis. The y value is 0, so that is a factor of the polynomial based on what we know about factors and roots and whatnot. So again, synthetic division, remember if we have k minus 2, that means that the actual k value using zero product property is k equals 2, and that's what we're going to use to divide. So we have 1, -1, -1, -2, no placeholders needed because we start from 3, go down to 2, 1, and then our constant term. That's exactly what we expect to see. So again, if we have a degree 3, you should have 4 terms up here. If you have a degree 4, you should have 5 terms up here, and so on and so forth. Okay, so 1 we bring down. 1 times 2 is 2. Add, and we get 1, multiply. 2 times 2 is 4. Multiply 1 times 2, which is 2. Add, we get 1 again. Multiply 1 times 2 again, we get 2, which gives us 0. So that's what we were looking for, right? That remainder of 0 tells me that this is a root. It is a root because we have that remainder of 0. Again, that means that the point 0 is on this function, and based on what we know about roots, they always are zeros, right? So they always have a y value of 0. Okay, in example 9, you start with -8, then you do 1, 9, 14, 5. We got a placeholder here of 0 because we do not have a hold on one second. 4, 3, 2, 1, 0. What did I do there? Did that one wrong in my example notes here. We do not need a placeholder here because we go all the way down. So we have 50 and then 9. Okay, so let's see if this one's going to work. Bring down our 1. -8 gives me 1. 1 times -8 is -8. Add, and we get 6. Multiply, and we get -48. Add, and we get 2. 2 times -8 is -16. -16. When we add those, we get -7. That is not a remainder of 0, so no, this is not a factor. It is, however, a point, 8, -7, on the polynomial. But no, it's not a factor. N plus 8 is not a factor. Simply the point -8, 7 is on the function. Okay, in the last set of examples, you're just asked to divide here. So what you want to do is just take, again, your actual value. So if we have a factor of p plus 6, that means that p actually equals -6. So that's what we're going to divide by using synthetic division. We're really dividing by p plus 6, but what we use is the actual 0 value, which is -6. Then we're going to put in our values of our constants here, or coefficients rather. So we have our leading coefficient of 1, 5, -11, -25, 25, and 29. Okay, synthetic division again, bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. Okay, so what we get here when we divide, notice we have a remainder, so this is a remainder of -1. The rest of these represent our terms. We started with a degree 4. We divided by a linear. This is a degree 1 term. So using our rules of exponents, if you have p to the power of 4 over p to the power of 1, when you subtract those exponents using exponent rules, you get p to the power of 3, and this is just division. So that's exactly what happens with this polynomial. So we had a degree 4, we divided by a degree 1, so we're going to end up with a degree 3. So 1 goes in front of x cubed, which we don't need to write, -x squared minus 5x plus 5, and then we have minus our remainder here, -1 over p plus 6, which is what we divided by. So remember when you did long division back in the good old days, if you got a remainder, it was the same as whatever that remainder was divided by what you originally divided by, because remember it's left over and it has not yet been divided by that p plus 6. So that's just another way to write it. In the answer key, they just write r -1. So it has a remainder of -1. Two different ways to write it. For now, I just need you to understand that if there is a remainder, that means this is not a factor. It is not a root. So that is the key part here. And then I need you to understand how to do all this synthetic division. Hope that helps. Come to office hours if you need more. Miss you guys.